In this short video, we are going to talk about test crosses. So what we've got here, we have got a lovely monohybrid cross that we talked about in our previous video. If you haven't watched that yet, you must go back and watch it. And if we look at this example here, simple dominant recessive inheritance pattern, we've got big B being dominant over little b, and big B must be a purple colour flower, and little b is white, like this. And you've got your lovely cross. You know that both of your parents were heterozygous. And then you've got your lovely offspring, and you've got your nice 3-to-1 ratio between purple and white. So that's great because you knew the genotype of your parents. But what happens if you only know the phenotype? So remember, phenotype is what the colour looks like. If you've got your phenotype, if you have a white flower, that's your phenotype, you know because of the recessive trait, then its genotype has to be little b, little b. The problem is if you have a purple flower. Purple flower has to have at least a big B, but they could be homozygous dominant or they could be heterozygous. And what a test cross is used to do is to work out which of these you have. And I'm going to show you how to do that today. So just to go through that again, just to make it very, very clear, use a test cross when you know the phenotype, but you don't know the genotype. And remember, we were looking at the big B, little b example, like this. So if we have the recessive trait, so if the flowers are white, then we know that they are homozygous recessive, like this. If, however, they have the dominant trait, so they are purple coloured flowers, then we don't know whether they are homozygous dominant, big B, or heterozygous, big B, little b. And that's when we would use a test cross. What you do with a test cross is you cross your unknown individual with the recessive trait. Okay, so it's a cross with recessive individual. So we are going to use our big B, little b version again. So we're going to remember that big B is dominant to little b, big B is purple, little b is white. So the individual we're going to be crossing with is little b, little b. So we have purple flowers plant. I should be doing this in a purple colour, shouldn't I? So we've got a lovely purple colour plant. There you go. And we don't know whether it's big B genotype or big B, little p. But we can perform a test cross, and we are going to make it with a homozygous recessive individual. So just like we looked at in monohybrid crosses, we have to work out the gametes and do a Punnett square. So if we do this example first, so we've got little b homozygous recessive gametes, and then if our parent is homozygous dominant, then all the gametes will be big B, big B. And if we do the cross, and then we look at the phenotype of the parents, so anything with a big B is going to be purple. That tells us that this offspring would be 100% purple. What would happen though if the individual was heterozygous purple to begin with? So let's have a look. So again, nice Punnett square. And again, we've got big B, little b heterozygous, and we're mating it with the homozygous recessive individual. So we're going to write down our predictions like this. So this is just a monohybrid cross. Then we look at what we've got, And if it's got a big B, it's purple. If it only has little b's, it's white. And if we look at the individuals in this case, what we find is we have a one-to-one relationship between purple and white. So if you do this cross and 50% of your plants are purple and 50% are white, then that tells you your original parent was the heterozygous cross. So that's the power of a test cross. Okay, it's your turn to have a try now, and I've picked you a particularly weird looking cross. So what we're looking at here is some rabbits. So we're going to say in rabbits, having hair, I guess technically it's fur, having hair is dominant to being hairless. Okay, so if we wrote that down, big H dominant to little h. So this is hair and hairless. This is a rabbit with hair, and this could be big H, or big H, little h. This picture is a hairless rabbit, and he's definitely little h. And you have a hairy rabbit. There's a weird sentence. You have a hairy rabbit. So that's its phenotype. How can you determine genotype? This could be a 5-mark exam question. So pause the video and I want you to write this down and we'll have a look at the answer. Okay, so you've got your hairy rabbit and you don't know if your hairy rabbit is big H, or big H, little h. Who knows what your hairy rabbit is? But you are going to perform a test cross. And you are going to cross it with the homozygous recessive. So you are going to make your hairy rabbit mate and have babies with a hairless rabbit. Okay, and remember we do our Punnett square nicely. So if you are homozygous dominant, this is the cross you should have wrote out. And what we'll find in this case, they've all got the big H, so the offspring would be 100% hairy rabbits. However, if your original parent was heterozygous, you'll see something different. So again, heterozygous gametes, like this. Write down your offspring. And in this case, what we're saying is 50% hairy, 50% hairless. Like that. Now, if I said this could be worth 5 marks, I'm going to show you where you would have got these marks. So you would have had 1 mark for saying test crossed, 1 mark for saying with a homozygous recessive individual. You will have 1 mark for saying that's a little h, 1 mark for doing the cross and writing the genotype, and another mark for doing the cross and doing the genotype. And I obviously can't count because that's 7 marks. But you'd have to get 5 of them to get the full marks. We'll have a go at this in class. Thank you.